Hello, welcome back to DataFight Academy YouTube channel. You are always welcome to go through our videos on data analytics concept. This video is the first for the advanced visualization in Python series. In this video, we will continue our discussion on data visualization in Python, but we want to look at some advanced concepts. Please, if you're yet to subscribe to this YouTube channel, go ahead and hit the subscribe button. It's not going to cost you extra data or extra charges. It's all for free. All right. And if you like this video that you're watching right now, please hit the like button. If you have questions or feedback for me, please feel free to drop your feedback or questions in the comment section. All right, let's get started. Python is an important and robust coding language for data analytics. We've said this again and again, and as well as data science. Python provides great functionality to deal with mathematics, physics, and graphical functions. In this series of videos, which is advanced Python functionality, specifically relating to pandas data frames and data visualizations, will be explored. And I have the following learning objectives for the series of videos and the modules. At the end of this collection of videos, the series we're going to treat, you would have learned how to navigate a pandas data frame. You'll be able to slice a pandas data frame and be able to produce advanced visualizations in Python. And I've structured into two different outcomes. We'll begin by working with pandas data frames, and then we'll look at how to create and draw insights from advanced data visualizations. So I have a data set that was extracted from Kaggle. It's a football player's CSV file. We'll start by importing important libraries and as well as importing our data sets. Yeah. So before we go further, I would like to restart this kernel. Restart and clear all the outputs, and then we can continue from fresh Jupyter Notebook. Okay. Awesome. So here are the libraries that we'll be using for this advanced data visualization in Python. We use pandas data frame, of course, to get in our data set into the Jupyter Notebook. We also import NumPy as NP to perform some numerical calculation. Then we have to import matplotlib as PLT. So this is another way of importing it. I can say from matplotlib import plotly as PLT, or you can say import matplotlib.plotly as PLT. And this other fantastic package, which is the first time I'll be introducing it in the series of videos on data visualization, excuse me, which is Seaborn, and Seaborn will be imported as SNS. Okay, so in this same cell, I'm getting in my data set used with the method read_CSV, and I have football players.csv. So this data set is stored in the same location as my Jupyter Notebook, where the Jupyter Notebook is situated or located. And I'm using the low memory equals false to just take away whatever low memory that is associated with the data set I'm working with. So let's run this cell to import the libraries and as well as get the data into the Jupyter Notebook. So we would call our data set soccer. All right. And the very first step I would like to take before we even run this second cell, let's visualize. Let's just see how our data set looks like. So I'm going to call soccer, and then let's just display the first 5 rows by using the head method. So here is our data set. Our data set has about 39 columns, and it has the names of footballers of football players, their ages, their nationality, their overall acceleration, aggression, agility, balance, ball control, composure, and up to the preferred positions. Alright, so this is the data set to be working with. So if you look at these data sets, I think we should explore more. Let's go ahead and get so let's do something before we go further. I want to see soccer. Let's see if the columns. Let's get the columns of soccer columns, and these are the columns that are there in this data frame, all 39 of them: name, age, nationality, overall, acceleration, aggression, and the rest. Now when you look at this closely, you will notice that some of these columns are actually they are actually numerical, while some are categorical. Okay, to see what columns we have as numeric and what columns we have as categorical, I would like to just check out the info of the data set, soccer.info. So with the .info method, we should be able to get the different types of data type for each column. So when you call soccer.info, it gives you the list of the columns, right? The number of non-null values stored under each of the columns, and then it shows you the count of the non-null values as well as the D type, which is the data type of each column. So from here, you notice that a lot of our columns are objects, which means an object in Python is a data type for categorical or text data type. But when you look at the data set, it has numbers all over. So it means that this data set which has numbers are actually stored as objects and not numeric, which is not proper. Now there is just two columns that are stored as numeric, int64, which are the age and the overall. So what's the next step to take before you can perform any maybe visualization or analysis associated with numeric data sets? We have to convert all these data sets, which are actually numeric but stored as objects or as string. So what to do, or the best way to do that, or one of the ways to do that, is to use our to numeric method or to numeric attribute to convert it to numeric. But we want to select those columns that are numeric, right, from the list or from the data frame. There are lots of them, so we can't do it manually. We want to pick it out one after the other manually. So I went ahead to list the columns that are objects, whose data type is object, and I called a variable name for the list called col, like columns. So these are all the list of the columns that are objects. Now with this particular line of code, so what am I doing here? I'm saying for each column in this particular list, pick them and assign them to col. Pick each of these and put into the data frame, like you are trying to access that particular column in data frame, and that should be equal to the same assessment of the column in data frame, but this time around I'm converting it. I'm using the .apply method to convert it to numeric using the numeric attribute of pandas data frame. And errors equals axis 1. Axis 1 means that it should this effect should be applied to the column of that, to the entire column and not the row of that particular selected column. So when we run this particular row, this particular cell rather, and run this cell, Python is going into the data frame called soccer and picking each of these columns. You see it's still running. It picks each of these columns and converts all the data type from objects to numeric. And now that has been done. Okay, so I would like us to see the info again and then take note of what the effect that has happened after running that cell. We'll call soccer.info method, and this time around, as you can see, we have successfully converted all the objects columns to float. All the numeric columns that are stored as objects to float, while we have the objects as objects. So preferred positions should be objects, name should be objects, nationality should be objects. So there are just 3 columns that are objects or string, others are floats. This makes sense. So these are some of the things you begin to do as a data analyst. You have to check your data sets, do some inspection before you begin creating your charts or plotting your charts. Okay, so we can go ahead and check the first 10 record, and this is how it's looking like. So as you can see, we now have 0.0.0.0 because we converted those objects to floats. If we converted it to ints, then we wouldn't have the 0.0, rather we'll just have the figures in integer. But that doesn't stop or change our analysis. Now let's look at look at the descriptive statistics for each column to see if we can spot any anomalies. I run this cell for our descriptive. Okay, so here is the descriptive statistics. When you call .describe method to any pandas data frame, what it does is to calculate the following descriptive statistics: count, mean, standard deviation, minimum, 25 percentile, 50th percentile, 75 percentile, and the maximum. So these are some basic statistics that is being computed from your numeric columns in any given data frame. So it only applied to numeric columns but not non-numeric. Here we have the count of the age is 17,981, and that is the same count across all columns, just counting how many occurrences of those do we have. Then the mean age is about 25 years. The mean overall is about 66. The mean acceleration is about 103, and so on. The standard deviation for the age is about 4.6. Standard deviation is about 6.9, and the standard deviation here is 986, which is very strange. When you look at the standard deviation, the mean age is 103, and then you have the standard deviation as 986. So the standard deviation is sometimes meant to be smaller than the mean, but having it as a very large value here, that means we would be looking at what's causing that. All right, so just look through the descriptive statistics. That will give you some insights from what you've just looked at. Now we said that it would appear that we have 17,981 entries in total, with some NaN values, which is some null values, and some values that fall outside of the expected start range. We would have difficulty comparing an acceleration score of 67 with an anomaly score of 33,270. Okay, because when you look through, you can just check the minimum and the maximum. So we have the minimum age here to be 16, while the maximum age is 47, which is not. And if you have the mean as 25, then that makes sense, right? It's not so much of a problem. But this column that I cited, this standard deviation as 986 as against having a mean of 103, and I said there is every likelihood that there is a problem here. Now you agree with me when you look at the minimum value as 11, and then the maximum is 33,270. So which means that this guy is an anomaly. It's just outside the range. So there is something further investigation that is needed here. All right. So just by looking at the mean and the standard deviation, that can actually fish out some funny records. Same thing is applicable here. The aggression here is the mean is 77, while the standard deviation is 768. which is alarming. It has to be something that's supposed to be smaller. And now coming down to the mean, the minimum value is 11, and then you can see the maximum as 43,130, which also points to the fact that something is we have some maybe outliers and some anomalies in this column too we have to deal with. The same things occurred, the same thing happened, is same thing with the agility as well as the balance and so on and so forth. So we have to check out our columns and then know the exact issue to deal with. Okay, all right. So okay, like I said, we have anomalies of 33,270. Where we expected all scores to fall below 100. Can you see the scores are supposed to be below 100? So what we need to do to solve that issue is to convert all statistics that are above 100 to NaN and then see the summary statistics again. That's the first thing we want to do. So any statistic that is greater than 100, we convert it to NaN. All right, and then check our stat again. So here's the line of code I use in achieving that. For column in the soccer.describe.columns, so using the soccer.describe columns, this very columns here, yeah, what do we want to do? We want to pick the column and then calculate the new column by applying the lambda method and say give us the column x if x is less than or equal to 0, else replace that column with np.nan, and then we calculate the descriptive statistics again to see the output. Once I run this cell, we have our statistics. At this time around, you can see that we have some reasonable values. The mean age is 25 while the standard deviation is 4 for the age, which makes sense. The overall has a mean of 66 and a standard deviation of 6, which also makes sense. The acceleration has a mean value of 64, the standard deviation as 14. Now this makes sense, right? And then we have 55 against 17, which makes sense. So when you compare all of the mean and the standard deviation, we now have a reasonable kind of value, which is as expected. And then the minimum and the maximum is not so far apart. It's something that is still within reasonable range. So now we have a much better data set with all the anomalies removed. We can now easily compare the values that are available to us. All right, so this is just simple kind of cleaning that you need to do. Simple kind of what's it called? Observation, examination, and little data cleaning that is expected of you as a data analyst before you begin any visualization or analysis. I'll stop here, and then in the next class we'll learn how to do some slicing and dicing, and then we'll learn also how to begin our data visualization. I hope you enjoyed this video and I hope you understand everything that we've said. If you have any questions, please drop your questions again in the comment section like I said earlier. And if you wish to join our academy, the Refied Academy, to learn more about data analytics, please reach out to us via you can drop a comment in the section, say I'm interested, or you can check us out via social media handles, and we'll be there to respond to your queries and also give you further information of how to join our academy. For now, that'll be all for now. Thank you very much for watching. Please don't forget to subscribe, like, and share this video. I'll see you again in the next one. Bye bye.